The essential question for this unit is, what does it mean to do work? By the end of this video, you should be able to define energy, differentiate between the different types of energy, and calculate changes in potential energy. Energy is defined as the ability to do work. There are several different types of energy, but mechanical energy is the energy due to the position or motion of an object. So there are two types of mechanical energy, potential energy and kinetic energy. We are going to be focusing on potential energy to start with, which is stored energy based on the position of an object. There are three types of potential energy: elastic potential energy based on stretching or compressing springs, chemical potential energy, like we talked about in chemistry, energy stored because of the bonds of compounds, and gravitational potential energy, which is the potential energy that an object has because of its height. That's the one we're going to be focusing on in this lesson. Work must be done against gravity to elevate an object. So the potential energy due to gravity is the work done on an object to raise it. If you remember, work is equal to force times distance, and the force for lifting an object is its weight, which is mass times the acceleration due to gravity times the height. And since the potential energy due to gravity is the work done to raise it, potential energy due to gravity is also mass times the acceleration due to gravity times the height. You do need to be very careful when you're plugging into this equation. It's mass times gravity times the height. However, sometimes questions might give you the weight of an object, which has already multiplied the mass times the acceleration due to gravity. So we can also call it weight times the change in height. 0 joules of potential energy is somewhat arbitrarily chosen. There really is no zero. Oftentimes we call 0 potential energy the ground or the floor. However, if we were to dig a hole, the object would fall lower, so it really does still have some potential energy. So we can call whatever elevation we want a potential energy of 0. Here the question says to find the gravitational potential energy relative to the ground. It's specifically stating that we are calling the ground 0 potential energy of a 65 kilogram person sitting on a diving board that is 3.0 meters high. So we know that potential energy is equal to mass times the acceleration due to gravity times the height. We're looking for potential energy. So potential energy is equal to, it is giving us mass, which is 65, times gravity is 9.81, times the height, they are 3.0 meters above the ground. And if I multiply that together, I get the potential energy is equal to 1912.95 joules, which, once I take into account significant figures, the 65 and the 3.0 both only have 2 significant figures, and gravity has 3 here. So it would be 1,900 joules of potential energy. This question is dealing with a cliff diver who is dropping from a height of 46 meters, and it tells us that during this drop, his potential energy is decreasing by 25,000 joules, and we're looking for the weight of the diver. Now, it's telling us the change in the potential energy and the change in the height. So the change in potential energy is 25,000. And it doesn't give us the mass or gravity. We're looking for the weight, which is mass times gravity. So I'm going to just plug in a W for mg. And then the height is 46 meters. When I solve that for W, I get W is equal to 543.4782609, which when rounded to two significant figures gives me a weight of 540 newtons. Again, the trick is you need to be careful whether it's talking about mass or weight. The change in potential energy is the mass times the acceleration due to gravity times the height, or just weight times height.